Drones are versatile tools that can be used for a wide variety of applications. One of the newer use cases for drones is to help create 3D models, thanks to special software programs that can turn aerial images into digital spatial models. Here's what you need to know about 3D models, how you create 3D models with drones, and how these 3D models are being used across different industries. First, what is a 3D model? It's a three-dimensional representation of an object created by plotting individual points in 3D space along the X, Y, and Z axes. The points are connected by geometric shapes, such as triangles, lines, or curved surfaces, to form the model. You can create a 3D model manually by using 3D modeling software, by using an algorithm, or by scanning a physical object. And this is where drones come in. Drones are essentially airborne scanners that can be used to turn large objects, such as buildings, construction sites, or simply large land areas, into 3D models thanks to a process called photogrammetry. Photogrammetry is the science of making measurements from photographs, particularly aerial photographs. The way photogrammetry works is it looks at photos of a subject taken from two or more locations. It uses the different perspectives of the images, along with the location data of where the images were taken, to triangulate the locations of points on the subject. The more photos you have of your subject taken from different locations, the more accurate this triangulation process will be. The result is accurate point locations plotted in 3D space, which is exactly what you need to create a 3D model. Drone photos are great for this process because every photo is geotagged. This means the latitude, longitude, and altitude from the drone's GPS and onboard sensors are embedded in the metadata of the image. The metadata also includes information about the camera sensor and the optics of the drone. These geotagged photos can be processed by software programs such as Drone Deploy, Pix4D, and others to create 3D models with high detail and accuracy. To get the best results of creating a 3D model with your drone, you need to do two things. First, you need to make sure there is a 60 to 70% overlap between your aerial photos. This helps the triangulation process be more accurate and track the same points between images. Flight apps such as Drone Deploy and Pix4D Capture allow you to create automated flight paths and set your desired image overlap. The second thing you need to do is make sure you capture photos of your subject at different angles and altitudes. Typically, you want to capture straight down images from around 100 to 200 feet. Then you want to circle your subject at a high altitude with about a 30-degree angle. Next, fly at a middle altitude with around a 45-degree angle, and lastly, fly at a lower altitude with a 70-degree angle. You of course also want to adjust your radius to keep the subject in frame. Capturing these different angles and altitudes helps create a higher quality 3D model by providing texture and image data of both the sides of the building and the top of the building. You can then use a software tool to process your images and create your 3D model. You can find more information on creating 3D models with your drone in our article linked in the video description. So, how are these detailed 3D models being used across different industries? The construction industry has seen a huge benefit from drone imagery, mapping, and 3D modeling software. Construction firms can monitor progress of their construction sites with regular updates, and they can easily inspect different areas on the site. The accuracy of the 3D models also means they can be used to calculate distance, area, and volume measurements. Land surveying has also seen tremendous benefits from drone technology. Not only has it gotten easier to get an up-to-date view of a landscape, but you can create detailed bare earth models, digital surface models, and true orthomosaics, along with generating 3D models of the terrain. Firms specializing in inspection services can also utilize 3D models and drone mapping technology. They can safely inspect previously unseen angles of properties and equipment more safely and more efficiently. They can spot potential problems with detailed 3D models, add annotations, and see the original imagery for a better look at a particular area. Energy firms benefit from these kinds of tools as well. Much of their equipment is larger, more dangerous, or in challenging to reach locations. The ease of inspecting equipment with drones and 3D models can help make sure inspections happen more frequently, reach more dangerous or challenging to reach locations, and help ensure the safety and longevity of the equipment. The agriculture industry is another area where drones are transforming the landscape. While farmers are not necessarily using 3D models, they can still leverage data from drones to create orthomosaic maps of their fields. Newer drones are available with multispectral cameras, allowing farmers to create normalized difference vegetation indexes for a deeper understanding of their crop health and field performance. Public safety can also utilize 3D models for documenting and recreating crime scenes, recording evidence, and providing a clear picture for investigators, forensics, and jury members. Officials can even gather imagery and data in the wake of natural disasters in areas typically unsafe for people. And finally, architecture and engineering firms are using 3D models to create detailed and realistic context models of their buildings or development projects. These models help architects communicate their final design to key stakeholders and investors. And across all of these industries, drones are making it safer, faster, and more efficient to gather meaningful data while reducing liability and risk.